Okay, so last week when we were doing the balancing chemical equations, we talked about, there was one question that was like, what type of reaction was this? And we skipped it because we're going to talk about that now. So for classifying chemical reactions, you're just, going to ask yourself these questions. So first, if there's only one reactant, which side of the problem are reactants on? The left. So if there's only one thing on the left side, then that would be decomposition. One thing is going to break down into multiple pieces. Okay?
Like me?
Like you?
Yeah.
Perhaps. Depends on the day, right? Well, that's more than one thing, so that is not decomposition. Okay. So one piece on the left will decompose into multiple pieces. If there's only one product, which side are the products on? The other side would be the right side.
It's like a multiplication problem. If you go in a normal way, the product would be what it would equal.
Yes, this. What is yielded or produced is what it equals. So if there's only one thing left at the end, your things got synthesized. They combined to make one compound. Okay? So, one thing breaks down is decomposition. Some things combine is synthesis or addition. And then we get a little more specific. So this third one here, oxygen is a reactant. So oxygen on the left, and water is a product. So if we put oxygen in and we get water out, what is water going to look like in your formula? H2O. If you see H2O as a product, that is a sign of combustion. So hydrogen or a hydrocarbon burn in oxygen to produce water, energy, and sometimes, a lot of times, CO2. The CO2 isn't always there, but the water is. Okay? So here they've got hydrogen mixing with a hydrocarbon, CH. You get oxygen and some water and maybe other stuff. They are not sure. It depends on how many of those carbons and hydrogens you have. But hydrogen just combining with oxygen to produce water is combustion. CH4 with oxygen makes water and carbon dioxide, which is still also combustion. Okay?
What causes spontaneous combustion?
Hydrogens. What did you say? That is a great question. Why is 2H2O not the same thing as H4O2?
Because your O would be up there as well.
Okay? So we talked about this when we were balancing equations. Does 2H2O equal H4O2? Is H4O2 water? No. So this is why.
Yes, what it was.
Do you know what it is? There's no carbons in there. We can look it up. Hold on a second. All right, so give me some grace here. H4O2 is called oxonium hydroxide.
What the heck is that?
I don't know. But it's not water, right? should not.
You shouldn't try things you're not sure of anyway.
So, why are these not the same?
Obviously, that's not the same name. I don't know what the heck you just said.
It doesn't have the same name. It doesn't have the same compound. Yeah, the molecules are different. 2H2O means what? We talked about this was like an oxygen with a couple hydrogens on it, right? Oops. I have no idea what H4O2 looks like. But it would have, let's just put them in the middle. Oh, those are too small. I don't know that it would look like a caterpillar, but we're going to pretend that it does. But those are not the same. I think that's a clue.
There's so much more.
Yes?
Still, I have a stabbing pain in my foot.
What does this 2 in front of the H2O mean? There's 2 molecules of water. Okay? So your coefficients tell you there's multiple molecules, not that there's a different formula. Okay? So that was a great question, and it's very important for these formulas. Anything else before we move on? All right, our next one says an element and a compound make a different element and a different compound. Before we talk about those things, just what is an element? Yeah. Yeah, just one element is going to be like a single letter, or some of our elements have like sodium is Na, but one thing, single, what is another word we used? I don't know. Compounds are what? They're what? A group, yeah. There are multiple elements in one compound combined together. Okay, so if they just switch spots, but one of the elements is still by itself, this is called single displacement. That single helps you remember there's just one. So they made this up. A plus BC becomes B plus AC. The thing by itself is different, but the rest is still a compound.
The one on the bottom doesn't make sense.
It what? Oh, okay, hold on. Okay, so single displacement, one thing gets left out of the compound. All right, and then our last one is 2 compounds, so 2 sets. Become 2 different sets. This is double displacement, so multiple things. And yes, like Tyler said, this should have a B there still. So AB plus CD is going to become AD and BC. Or with actual elements, we had MgO plus BES. Yeah. The S switches spots with the O. Magnesium something sulfur, sulfide, I don't know. Sulfate. How many depends on which ending it gets. Beryllium and oxygen, I don't know what they make together, what it's called. But basically 2 parts, switch spots. Okay? Okay, on the bottom of this is the exact same thing, just as a table. So we talked about decomposition breaks things down. Addition puts things together. Addition is also called what? Synthesis. Addition or synthesis. Combustion burns oxygen and forms water, and sometimes CO2. Single displacement takes one thing and switches it. Double displacement switches 2 things. Okay, go ahead and turn the page. We have some reactions. We need to decide what type they are, and then we're going to balance them like we did last week. So for this first one here, NaS plus ZnO3, ZnNO3 becomes NaNO3 and ZnS. Double displacement. 2 things switch spots there. Double displacement. All right, and then remember, balancing these is just trying to get the same number. So we have N's, NA's, S's, CN's, N's, and O's. All right, if we look at the other side, same thing. NA, I'm just going to list them in the same order so it's easier to compare. ZN, N, and O. 1, 1, 1, 1, and 3. Okay, so are those different or the same? They're all the same. So if I don't need to change anything, what do I put in these blanks? Ones. Right? So 1 NaS and 1 ZnNO3 will combine to make 1 NaNO3 and 1 ZnS. All right? What about the second one? Lithium plus 2 nitrogens becomes lithium 3N. What's happening here? Yeah, we're putting things together and getting one product, right? Instead of calling it addition, we're going to use the synthesis word. Synthesis. Okay. We've got lithium. We've got nitrogen, lithium, and nitrogen. How many lithiums on the reactant side? 1. Nitrogens, 2. 3 on the product. And 1 for the nitrogen. All right, so look at these. Look at one letter, one element at a time. How am I going to make 1 become 3? 3? Oh, is that going to work? No. Okay, so we also need to take into account these nitrogens. Since there's only 1 nitrogen in the combination, let's start there. How many nitrogens do you need to match? 2 on which side? Li3N needs to be 2. 1 on the other side. Okay, so that switches. So now we've got.
6, 1, 2.
Hold on. Does that work? That stays 2. This one becomes 2. All right. So our ends match. Okay. This is actually worth 6 now. So I need this one to also be worth 6. 6 times 1 is 6. Okay. So 6 lithiums plus 1 N2 will become 2 lithium 3N. But it makes sense, right?
I got it right, but I don't. Well, because my biology is kind of intertwined with it,
Yeah.
and I had to do one of these, I was like, I probably went over it. But I was sitting here for half an hour trying to figure it out, but I got it right.
Well, that's good. For these, you're just looking at what multiplies to make these match. Before we decide what numbers, what type of reaction is happening? What's happening? It's what? It's changing.
Is I think you've got O2
Yeah.
on one side, but only no, so it'll be double, it'll be double.
We had one thing at the beginning, and it broke down into multiple things, which is called decomposition. Composition. Okay? We have K's, CL's, and O's. One. All right, so what do we need to start with? The O's. So this first one needs to be a 2. What happens to all of these? They all become 2. 2 times 1 is 2. 2 times 1 is 2. All right, good. KCL needs to become a 2, but then we want that O2 to stay 2. So this just is going to be a 1 in front. Hold on. Any questions about that one? All right, what's happening on this next to last one? We had things combining, and what happened? Water and CO2 is, but when that's what you get, you have combustion. Okay, so C, H, and O. The C is a 1.
H is 4, O is 2. 1, 2, 2, 1.
The C is
Is
1.
1. O is 3.
O is actually 3. Be careful there. They're broken apart, but there are 3 total. All right. So let's start with the O's. What number do we need to get to if we have a 2 and a 3? 6 is a multiple of those. Think your numbers in front are multiplying. Okay? So what should we put in front of this first O? A 3. That will change this one.
Look at the C's to make sure.
Okay?
Well, for the other 2, look at the other 2.
Yeah, so look at C. Before we decide which O to put our number with, we've got C's that need to match up and H's that need to match up. Which one definitely needs a number? The H's. So how many H's? Okay, so what number, if there's 4 over here, what number do we need for this H2? A 2. We've already got H2, so we need to multiply 2 by 2 to get 4. What happens to our O's if we do that?
The 1 will be
This will be 2 O's. Becomes 4. You're right.
That's why I was confused. I was like 1, 2, 2, 1.
It felt like we were going to need to make more, but we don't. You're right. Okay, so 4 O's on both sides. everything matches if we do that. So the others just get a 1. Good. Sometimes you just have to guess and check and go back and change things if you didn't get it right the first time. That's okay. Does everybody get what we were doing there, though? Okay, what's happening on this last one? Yeah. MG was left out first. AG got left out second. But that's just, whoops, one thing. Single displacement. All right. MG, I need to move that over. AG, N, and O. MG, AG, N, and O. All right, how many do we have on the left? 1 MG, 1 AG, 1 N, 3 O's. All right? Careful.
No, it's on a parenthesis, so the MG is a 1.
Good. This parenthesis goes with that outside 2. The MG is not in there.
The N would be a 2 and the O would be a 6.
The N would be a 2 and an O would be a 6.
And AG is 1.
AG is just 1. Okay, so whenever they throw in parentheses, whatever's outside of it only goes to the things inside. What should we change first? Yeah. Take care of, so we have 3 O's and 6 O's. So we need a 2 for that AgNO3. That gives us 2, that gets us 2. And then our O's. The other AG just needs a 2. The MGs don't need to change, so 1 and 1. Good. Everybody feel all right about balancing equations? Love to hear it. All right. This bottom part here, just a couple extra things. We talked about this a tiny bit when we were doing our experiments. If something is endothermic, it's absorbing heat. Heat enters. They highlighted enter. They feel cold, but they're absorbing heat. Exothermic, heat exits. So if you're releasing heat, you're hot. Okay? Feels a little backwards, but those are there. And then, where does this heat come from? Chemical bonds. When bonds break or form, they release energy or absorb energy. And a lot of our energy is felt as heat. Okay? They got very specific. These are covalent bonds. And when they break, they produce heat. And in this case, also water. All right, so we got which type of reaction is always exothermic? There was one keyword in your list. Exothermic means what's happening to your heat. It's releasing. This is going to feel hot. So if you look back at your types of reactions, There's one that's always going to feel hot because it's doing what?
Releasing the heat.
What do you say? No. It's combustion. Why is it combustion? Because explosions. Kind of. Every time something combusts, what is happening? It's burning what? It's burning oxygen. The substance burns in combustion. Yeah. whatever it is, I forgot an S. The substance is going to burn. Yeah. Yeah. Okay. When something burns, it usually produces heat. And what other way do you show? Okay. Gotcha. Like you can actually feel the heat or thermal energy. What's the other type of energy that burning usually produces? Heat or what else does a fire do? Yes, it is all of those things, but fire is hot, and what other energy is coming out of it? What else do we use a fire for besides warming up? That uses the heat part. So combustion is usually hot and produces light. Any questions about these types of reactions?